Hey there, Austin Lyons here from ChipStrat and Creative Strategies. I published a post today called Reasoning Models in DeepSeek, which takes a look at the impact of reasoning models on the AI accelerator industry. I'll give you a quick summary in this video, and if you want to learn more, head over to chipstrat.com to read the post. We begin with a quick overview of reasoning models, starting with OpenAI's O1 model, the first reasoning model to exist. Remember, a reasoning model is one that can simply have internal dialogue before it responds to the user. No more just saying the first thing that comes to mind like GPT-4 does. Instead, the model can think. So next, let's dive into DeepSeek's reasoning models. First is DeepSeek's R10 model. DeepSeek started with their thinking fast GPT-4o-like model, which they call V3, and it's very efficient, by the way. And they performed reinforcement learning, or RL, on this model. And out popped R10. Of course, I'm keeping this very high level. What's crazy is that no chain of thought reasoning data was provided here as an example to the base model. Rather, DeepSeek just did RL on this V3 model, and chain of thought reasoning simply emerged from the RL process, which was pretty wild. Regardless, this model has issues, this R10 model. Like, it switches back and forth between Chinese and English mid-chain of thought sometimes, which of course can make it hard to debug, and for Americans, maybe hard to trust. So DeepSeek tried again, this time with a relatively small amount of what they were calling cold start data, which was chain of thought example data. So this chain of thought example data was used to fine-tune the base model before performing reinforcement learning. The output of this process was much better, and they call it DeepSeek R1, which is their reasoning model. Next slide. Back to OpenAI. So OpenAI to date has shown us 3 compute scaling laws. So the original scaling law that everyone got excited about and drove the GPT-3 to 3.5 to 4 is pre-training scaling, which is the original scaling law, where you increase compute, training data, and model size simultaneously to get more intelligence. Now, OpenAI, with their reasoning model, their proprietary reasoning model, also introduced 2 more scaling laws. The second one was this train time scaling, or reinforcement learning scaling, which is spending more compute, more time thinking during reinforcement learning to get better outcomes. So during the reinforcement learning, if you spend more compute on each example, then you can get better results. And then the third scaling is test time, or inference time scaling. So note that the first 2 were during training. If you spend more compute, you can get better results. And this last one is during inference. So when the model is making predictions, when it's answering a question to a user, if it spends more time thinking, you can get a better result. So to illustrate a bit, I tried to kind of draw this out. Pre-training scaling brought us GPT-4. RL scaling can make for better O1 reasoning. So the more it thinks, the better reasoning as you spend compute there during reinforcement learning. And then lastly, this inference scaling allows for more expressed intelligence from the O1 model. If you let it think for longer, it's going to have a better response. It's like if you ask Einstein to give you an answer in 5 seconds or to give you an answer in 5 minutes, which one's going to have a better result? Well, of course, letting Einstein fully express himself over 5 minutes or 50 minutes or 5 hours, you're going to get the full capacity of his intelligence as opposed to 5 seconds. So that's a new vector of compute demand, is letting users say, maybe there's a business model implication too here, I'll pay more to get more expressed intelligence at runtime, at query time. Okay, so what's the point of all this? Well, there's lots of implications. You can go read it all at chipstrat.com. But basically, DeepSeek's previous V3 paper, which we didn't cover much here because we were covering R1, the reasoning model, but the sort of thinking fast GPT-4o-like V3 model from DeepSeek explained that they can very efficiently train V3 and very efficiently serve in predictions or run inference, which of course is what got everyone all up in arms. But nothing about DeepSeek's V3 or reasoning models suggests that these scaling laws are dead. Now, of course, Ilya says pre-training scaling is dead, but that's really just bottlenecked on training data. We've read the entire internet. Where will we go get more data? Because again, you need to scale compute and data and model size. But the industry so far is telling us that it still wants a higher intelligence ceiling. No one is saying, let's stop here. We've got enough intelligence. This is good enough. If they did, then it would be all about cost optimization. And maybe we'd be concerned, hey, we can get this intelligence now with fewer GPUs. But that's not what people are saying. They're saying we want a higher intelligence ceiling. And on top of it, DeepSeek did nothing to kill pre-training scaling. Again, it's a data issue that's the bottleneck. Now, on the contrary, reasoning, OpenAI's O1 reasoning opened 2 more vectors for scaling. They flung open 2 more doors and said, hey, there can be more compute demanded, on demand, and maybe with actually ROI that you could tie to it by doing inference scaling. And then, of course, there's also RL scaling. And DeepSeek walked in and they flung these 2 doors wide open because they said, guess what? We'll share our models with everyone. We'll share our approach with everyone. And so now suddenly we can expect way more AI labs to create reasoning models. And, maybe they are already, but regardless, now we can expect the industry to increase the amount of RL scaling during training of these reasoning models. And interestingly, because inference is going to be much more compute demanded than training, we can expect more inference scaling across the industry. So this is a totally new vector. We're probably barely seeing it yet. And all of a sudden, DeepSeek said, hey, have our reasoning models. Here's what we're doing. Everyone go create your own reasoning models. So we can expect that the industry will see more and more inference scaling over time. So Anthropic will have reasoning models, XAI will have them, et cetera. And so we'll have all these reasoning models and they'll collectively do a lot of thinking, in which, of course, by the way, thinking is expensive. So next slide here. The thinking slow O3 reasoning model, if you look at OpenAI's API prices, it's 7x more expensive per token than the thinking fast GPT counterpart. And by the way, it generates more tokens per response because it's doing all that internal dialogue. So lots of compute needed. It's expensive. More and more people are going to be have these reasoning models because reasoning is what you need for agents, right? They need to be able to reason because we can't describe the long tail of problems that they'll interact with. So they need to be able to reason through it on their own. This reasoning takes more compute in and of itself to do these predictions, right? It might be, its internal dialogue might be 2,000 tokens. And then on top of it, we might have people that say, hey, I want these agents, let them run. I'll pay for it. Just let them go until they get done. So there are many more insights in the article. You can go check it out at chipstrat.com. But the high level takeaway was that reasoning's awesome. It's DeepSeek is opening the doors up for everyone to do it. And they showed that you can do it at the edge, which has lots of really interesting implications. Can I use NVIDIA's Project Digits and have my own little suite of agents that are just little reasoning agents that are running around doing things for me in the background? And how does that impact compute demand? All right, go read it. Thanks for watching. Talk to y'all later. Let me know if you like this. I'm just winging it.